Question 31 says a particle A moves with a speed of 10 meter per second in a frictionless circular fixed horizontal pipe of radius 5 meter and strikes with B identical to that of A. The coefficient of restitution is 1 and the particle A starts its journey at t is equal to 0. The time at which the second collision occurs is something that we have to calculate. The student, for the first collision, the speed is given as 10 meter per second and the time taken will be the distance, that is pi into 5 divided by the speed 10. So this will be equal to pi by 2 seconds. So this is the time for the first collision. For the second collision, dear student, the time will be 2 pi into 5 by 10, that is the remaining distance. So this will be equal to pi. Please note, as the coefficient of restitution is 1, this means that it is a perfectly elastic collision and the velocities get exchanged. The total time capital T will be equal to T1 plus T2, that is pi by 2 plus pi, and this will be equal to 1.5 pi or 3 pi by 2 seconds. And hence for this question the correct answer is option number 3. Moving on to the question number 32. In this question, two objects of same mass and with the same initial speed moving in a horizontal plane collide and move together at the half initial speed after collision. The angle between the initial velocities of the objects is. Dear student, let this be the state of the initial objects, this be the m, and it is moving with the velocity v, and this is another m moving with the velocity v. Let the angle this be theta and theta. Finally, they combine having a mass 2m and they move with the speed v by 2. From the linear momentum conservation, we can write down that mv into cos theta multiplied by 2 will be equal to 2m into v by 2, that is in the horizontal direction we have conserved the linear momentum. So this means that cos theta will be equal to half or theta will be equal to 160 degree. 2 theta, that is the total angle between the velocities, will be 120 degrees. And hence for this question the correct answer is option number 1. Moving on to the question number 33. In this question, a glass ball collides with a smooth horizontal surface in XZ plane with velocity which is given ai cap minus bj cap. The coefficient of restitution is e and the velocity of the ball just after the impact is something that we have to calculate. The student, in this question, the velocities component which is perpendicular or normal to the impact surface will reverse in direction. So if this is the surface and this is the initial velocity, that is given as ai cap minus bj cap, the final velocity will become ai cap plus ebj cap, that is the j components get reversed. This is the given xz plane, and we can see that the correct answer for this question therefore should be option number 2. Now moving on to the question number 34. In this question, the moment of inertia of a uniform rectangular door of mass m, length 2l and width l about the longer side is. Dear student, there is a rectangle that is given to us. Now the width is l and the length is 2l. The mass is given as m. We have to find out the moment of inertia about the longer side, that is this side we have to find out. Now let us proceed and find out the moment of inertia. The student, for this the moment of inertia is actually mass multiplied by the distance square divided by 3, where distance is the perpendicular distance from the axis, where d is given as l. So this will be m l square by 3. And hence for this question the correct answer is option number 3. Now let us solve the question number 35. In this question, a uniform ladder of length 5 meters is given and it is placed against the wall as shown. The coefficient of friction between the ladder and the floor is given as mu while the wall is smooth. So we have to find out the minimum value of mu for the ladder to not slip. The student, let us proceed by writing down all the forces on the ladder. Let here there will be a normal N1, here a normal N2, there will be an mg acting at the center of mass. There will be a frictional force on the rightward direction, let it be F max. We are putting the maximum value of friction so as to make sure that the coefficient of friction is minimum. From simple geometry, this angle theta will be equal to 53 degrees. Now for horizontal equilibrium, F max should be equal to N1 and it should be equal to mu N2. For the vertical equilibrium, N2 should be equal to mg. So let this be the equation 1. Let this be the equation 2. Taking the torque about this point A and putting it to be 0, we can write down that mg into 5 by 2 cos theta, that is the torque of gravity, minus the torque of the N1 normal force should be equal to 0. Let this be the equation 3. From these three equations, we can easily find out that mu will be equal to 3 by 8. Meaning that for this question, the correct answer is option number 3. Now moving on to the question number 36.